So today we're going to be going over adding and subtracting square roots. So adding and subtracting square roots are very similar to combining like terms. Like for example, if you were given the problem 2x minus 3y plus 4x minus 5y, we're only allowed to combine our x's together and then our y's together. So 2x plus 4x, start out with 6x, and then minus 3y minus 5y is minus 8y. Here, we're not allowed to go any further because we have an x and a y, and those are different terms because they have different variables. The same applied to adding and subtracting square roots. If we have the same square root, then we're allowed to combine them together. If you have different ones, we cannot combine them. So let's take a look at some examples of that. So example 1 here. Let's say we were to have 3 times the square root of 5 minus 4 times the square root of 2 plus 7 times the square root of 2 minus 6 times the square root of 5. Now, here we have a square root of 5 and a square root of 2. So 3 minus 6 is negative 3 square root of 5. Negative 4 plus 7 is positive 3 square root of 2. So your final answer here is negative 3 times the square root of 5 plus 3 square root of 2. Now, not all the problems you're going to see are going to be as straightforward as this. We're going to look at some with a little more detail and a little more difficulty. So here, example 2. Let's say we were to have square root of 48 plus 3 square root of 12 minus 2 times the square root of 27. So for this, we're looking to simplify each square root first because we all have different ones and recognize that we need to take the prime factorization of each square root before we can add or subtract any of them. So 48 gets broken down into 3 and 16. 16 gets broken down into 4 and 4. We have a pair of 4's there with a 3 all by itself. So this now becomes 4 times the square root of 3. 12 gets broken down into 3 and 4. 4 gets broken down into 2 and 2. So we have a pair of 2's there. That gets moved out in front and multiplied with that 3. So that is now 6 times the square root of 3. 27 now, minus 2 times the square root of 27. 27 gets broken down into 9 and 3. 9 becomes 3 and 3. So we have a pair of 3's with that lone 3 left underneath our square root. So 3 times 2 minus 6 times the square root of 3 right there. Now, combining like terms, 6 square root of 3 minus 6 square root of 3, those both go away, and we're left with 4 times the square root of 3. All right, so last but not least, example 3. We have 2 times the square root of 72 minus the square root of 8 plus 3 square root of 5 minus 2 times the square root of 75. So for this, well, I'm looking to break down the square root of 72. That's 2 and 36. 36 becomes 6 and 6. So 6 now gets moved out in front. 6 times 2 becomes 12 times the square root of 2. Now, square root of 8 becomes 4 and 2. 4 gets broken down into 2 and 2. So it's minus 2 times the square root of 2 plus 3 square root of 5. There's nothing we can do there, so we just carry that down. minus the square root of 75. Well, that becomes 3 and 25. 25 now becomes 5 times 5. So we have a pair of 5s there. Combined with that 2 becomes 10. Remember, you multiply any number that gets moved out in front of your square root with anything that's there, like that 2. So it's 10 times the square root of 3. Now, we only have one like term here. That's 12 square root of 2 minus 2 square root of 2. And that'll be equal to 10 square root of 2 plus 3 square root of 5 minus 10 square root of 3. This is your final answer because there is nothing else that we can combine with any of the other terms because we have a square root of 2, a square root of 5, and a square root of 3. And they're all different, so that means we are done.